Let's look at the solutions of arithmetic bytes. A and B working together can complete a task in 15 days when both of them work for 10 hours per day at their usual efficiencies. Okay, so let's say efficiency of A was A and efficiency of B was B. So 15 days, 10 hours per day, A plus B. This is the total value of the task done by them. If A works for 10 hours per day at 50% more efficiency than his usual, and B works for 10 hours per day at his usual efficiency, the entire task would be completed in 12 days. Okay. So effectively, what do I have now? Total work done would be 12 into 10 into 1.5A plus B. This is what we will get. And in both these cases, work is identical. Total amount of work is identical. So 10 gone, 10 gone, 5, 4. I get 5A plus 5B is equal to 6A plus 4B, or A is equal to B. Basically, both these workers are equally efficient. A and B are equally efficient. Okay. So now total amount of work is going to be 15 into 10 into 2B. In how many days B alone can complete the task with his usual efficiency? If he works for 12 hours per day. He now works for 12 hours per day. Okay. So B cancelled, B cancelled. I have 15 into 10 into 2, 300 by 12. So the final answer that we get here will be 25. In 25 hours, B can complete the entire task. Oh, I could have done it smarter also. See, if together they are taking 15 days, working 10 hours per day, they would take 30 days. One individual person working 10 hours per day would take 30 days. If the number of hours are going up by 6 by 5, the number of days will become 5 by 6, so directly 25 days. But okay, this is coming to me later. Roger is twice as efficient as Novak, and Pete is 25% more efficient than Novak. Okay. So Roger, Novak, Pete. So if Novak was working at the rate of 4, Roger is working at the rate of 8, and Pete is working at the rate of 5. These are efficiencies. Okay. Roger can finish a task in 9 days less as compared to Pete. If we are looking at ratio of their days, we don't know the quantum of total work. If we are looking at the ratio of their days, it will be 5x. Roger and Pete only, 5x and 8x. It will be 5x and 8x. And what we have been told is 5x is 9 less than 8x. 5x is 9 less than 8x. So I can happily say x is equal to 3. So it takes Roger 15 days. It takes Pete 24 days. So total quantum of work is 120 units. 120 units. In how many days would Novak finish the same task? His efficiency is 4. Total work is 120. It will take him 30 days to finish the whole task. Okay. Profit on selling 4 books is equal to selling price of 1 pen, while loss on selling 20 pens is equals selling price of 1 book. Also, profit percentage on books is equal to loss percentage incurred on pens. What is the ratio of selling price of a pen to the selling price of a book if the cost price of a pen is half the cost price of the book? Okay, let's see. It is very easy to do if you have the ability to fix values, but I'll try to do it in a universal manner. So let's say CP, SP, the things I know, pen and book. So if cost price of book was 2x, cost price of pen would be x, according to the last line. If the cost price of pen is half the cost price of the book. Now let the selling price here be y, let the selling price here be z. So first thing told to us, profit on selling 4 books. So 4 times of Z minus 2x is equal to the selling price of 1 pen. So this is equal to y, first equation. Second, while the loss on selling 20 pens, so 20 times x minus y is equal to selling price of one book is equal to z. Also, profit percentage earned on books is equal to loss percentage earned on pens. Profit percentage earned on books would be z minus 2x by 2x. Loss percentage on pens would be x minus y by x. So this goes, z minus 2x is equal to 2x minus 2y, or z will be equal to 4x minus 2y. Okay, I can replace this in the second expression where I'm getting 20x minus 20y is equal to 4x minus 2y, or 16x is equal to 18y, or x by y is equal to 9 by 8. So if I assign these precise numbers to x and y, my work should be okay. X is 9, y is 8. So this will be 19. Now z was given to me as what? Z was given to me as how much? 4 into x. 4 into 9, 36, minus 2 into 8, 16. So z should be equal to 20. So this is 20. So finally, when we need the ratio of selling price of pen to selling price of a book, the ratio will turn out to be 2:5. So option C. Okay, so we didn't really need this. You can probably use this to reach precise values of all 3 variables, but because finally ratio is needed, you can happily skip the first expression also. Fun. A company manufactures widgets. Total expenses of manufacturing is partly fixed and partly varies with the number of widgets manufactured. The average cost of manufacturing widget is rupees 225 when 100 widgets are manufactured. Okay. Now see, there is this beautiful relationship when it comes to variation, part fixed and part varying. Can I say when the widgets are 100, the total expenses, not per unit, total expenses is 22500, and rupees 180 when 160 widgets are manufactured. So 160 widgets leads to total expenses of 28800. Okay. Find the average cost of manufacturing a widget when 240 widgets are manufactured. I'm saying when 240 widgets are manufactured, what would happen? What you can observe here is, see the count of widgets has gone up by 60. Total expenses have gone up by 6,300. If the total widgets have gone up by 80, the total expenses should also go up by 8,400. Basically, the ratio that you have here should be the ratio that gets maintained here, because the increase is only on account of the variable expenses. Fixed expenses remain fixed. So now I know the total expenses in the final case. 12 gone 372 followed by 2 zeros. Average I have to calculate. So 37200 divided by 240. Cancel, cancel. Is this divisible? Yes, this is divisible by 24. But it will be difficult. Oh, let's see. 1, 122, 5. No. 1, 132. So 120. Okay, 155 I will get. The average cost of manufacturing a widget will turn to 155 when 240 widgets are manufactured. I don't want to engage in the nonsense of what is the fixed cost, what is the variable cost. I can do that if that was the question. But here, because cumulative figures are asked, I don't need to engage in that level of detail. Okay, what quantity in liters of a solution of milk and water in the ratio of 5:9 should be mixed with 32 liters of another solution of milk and water in the ratio 9:7 in order to get 46.66% solution of milk. Here, I would expect you to be able to identify this number is 7/15. If you can identify this is 7/15, it would be very, very easy. Additionally, see 32 liters and 9:7 is given. So basically 18 and 14. What they're telling us is 18 plus 5x, whatever count we're using, plus 5x divided by 32 plus 9x should be equal to not 9x, I'm so sorry, plus 14x, 32 plus 14x, I have to look at the full mixture, has to be equal to 7/15. Okay, fun. So I get 18 into 15 to 70 plus 75x is equal to 32 into 7. So 224. I'm not certain. Yeah, 16 into 14. 224 plus 98x or 23x is equal to 46, x is equal to 2, which means we had 10 liters of milk and 18 liters of water. Okay. So what is the quantity in liters of the solution? The quantity of the solution would be 28. In case you're so inclined to go down the path of alligation, in the first solution, you have 5/14 milk. In the second solution, you have 9/16 milk. And finally, you need 7/15 milk. So if you try to find the balance, LCM would be 14, 15, 16. So 240 into 7, 1680. So this will turn to 5 into 120. 5 into 120. This will turn to 600. This will turn to 16 into 7, 112. So 784. And this will turn to 105 into 9. So 945. So the gap here is 184. The gap here is 161. Or the ratio is 8:7. So this will have 7 units. This will have 8 units. We already know this was 32 liters. So these 7 units will necessarily be 28 liters. In either case, in both these situations, you will reach a precise number. I choose not to go down the path of allegation in such questions because once you have a precise value available to you in the question, doesn't make sense to engage in all this fractional processing. Anyway, this is the end of this episode. Hopefully you learned something. That will be all. Okay, bye.